Hello everyone, my name is Evan Borelli and I'm an instructor here at Mathnasium of Hamilton Mountain. Today I'm making a quick instructional video regarding finding halves, and the title of today's video is Finding Halves, Divide and Conquer. And that's because there's this old war strategy, and it was used by the Roman ruler Julius Caesar and the French Emperor Napoleon Bonaparte. And it's called divide and conquer, divide and rule. And we find that we can actually use somewhat of a similar strategy, and it's found in the basis of these different algorithms in mathematics that we use today to resolve problems. One of those problems we can resolve is to find halves of various numbers. So the strategy we use to find half is to focus on breaking down a number into two or more smaller parts until they are nice enough or simple enough that we can split them in half mentally. Now, there are several layers to this that we really need to go over. And what hopefully that we can understand by the end of this video is essentially to find half of any number up to 1,000, but even greater than that, up to 10,000, up to 1,000,000, as long as we understand what we have to do in order to do that. So the first thing, of course, is to be able to find half of the even numbers between 0 and 10. So right here, I have drawn out 6 peaches or apples. I think they look a little bit more like peaches, but there's 6 of them. And what I'm going to do is I'm going to take half of those peaches, and we got to see how many we have, right? And we see that in that circle of half of the peaches, there are 3 peaches, which would tell us that half of 6 is equal to 3. And we want to do this for any of the numbers between 0 and 10 that are even. So you got 0, 2, 4, 6, and 8. And this is really the basis for all of the halving that we're going to be doing today. So understand that we can find half of even numbers kind of like this, right? We can a lot of the times picture scenarios in our head that can allow us to find half. We also have to understand what is half of one whole. And this will come in handy when we're finding half of odd numbers. You can see I've drawn out a beautiful, maybe it's a cherry pie, and we're going to take half of that. And when we take half of one pie, one whole, we are left with 1/2. And we draw 1/2, or we write 1/2 like that. It's 1 and a line 2. And that 2 comes from the fact that we have 2 equal parts. So half of one whole is 1 over 2, or 1/2. So we can use this knowledge to find half of odd numbers between 1 and 10. So let's take, for example, half of 9. What we're going to do is we're going to split up 9 into 2 parts. We're going to split it up into 8 and 1, right? So splitting up the number into 1 and the complement of that would make the number that we are targeting here. So half of 8 we know from before is equal to 4. And half of 1 we also know from before is equal to 1/2. And what we can do is we can take half of 8 and half of 1, so 4 and 1/2, and add them together. And it's exactly what I just said. It is 4 and 1/2. And that's how we would say that. So half of 9, that is 4 and 1/2. So that would allow us theoretically to find half of any number between 1 and 10. So even or odd. Half of 5, I know, is 2.5. And that's because half of 4 is 2 and half of 1 is 1/2. Half of 10, well, that's 5. I don't need to split my numbers up for that. Let's try one more. Half of 3. That's going to be 1.5. Half of 2 is 1, and half of 1 is 1/2. Now let's think of, in order to build our range farther than just 10, we need to understand half of multiples of 10. Okay, and for the example here, I have half of 60. And it's a lot easier than it may seem. What I can do here is half of 60 is equal to half of 6 times 10. Right? These are multiples of 10. So I know that 6 times 10 is equal to 60. So half of 60 must be equal to half of 6 times 10. Half of 6 is equal to 3. And 3 times 10 is equal to 30. Now you can see here half of 60, that is equal to 30. Essentially what I did was half of 6 times 10. That works for any multiple of 10. And it might be a little bit trickier for when the tens place is odd. So for example, half of 70, I will break that up into half of 7 times 10. Now half of 7, if I know from earlier, is 3.5. 3.5 times 10 is 35. What you'll notice is that when you're finding half of multiples of 10, they either end in a 0 or they end in a 5. And with this knowledge, we can really explore all of the possibilities of finding half of any number. Let's take, for example, half of 437. Now, that might seem like a bit of a reach from what we've been doing so far, but what I know is that I can break this up into many easier parts to the point where it won't feel so difficult. First, I'm going to kind of break this up into hundreds place, tens place, and ones place. So 437, I'm going to break it up into 430, and I'm going to break up 7 into 6 and 1, just like how I did in step 3. So half of 437 is equal to half of 400 plus half of 30 plus half of 6 plus half of 1. Now half of 400, that's not something we've seen before, but it's quite similar to in step 4, what we did there. Half of 400 is the same as half of 4 times 100. So half of 4 is 2. 2 times 100 is 200. So half of 400 is 200. Half of 30, well, I know that half of 3 is 1 and 1/2. Times 10 is 15. Next, half of 6, that is simply an even number between 0 and 10. Half of 6, just like in example 1, is 3. And half of 1, as in example 2, is 1/2. Now, maybe the trickiest part of this all is to add it all together. 200 plus 15 plus 3 plus 1/2. That's equal to 218 and 1/2. And really, this works for everything. Of course, the steps increase as you increase the values of your numbers, but the algorithm remains exactly the same. We are really focusing on being able to split our numbers into these simpler parts in order to make it easier to split them in half. So I encourage you to have fun getting better and practicing this concept. And for now, we're going to say goodbye from Mathnasium.